widely used as local area network for general purpose computing. Because of its ubiquity, that is, it is available in a simple manner and low cost of Ethernet interfaces, it has seen significant use as a network for embedded computing. Hence, in most of the embedded applications, Ethernet is used. This is used in applications when PCs are used as platforms and when the network does not have to meet any rigorous real-time requirements. When compared to the I2C bus, which we have learned before, the nodes on the Ethernet are not synchronized. That is, they can send the data whenever required. But that is not the same in the case of I2C bus. In I2C bus, each node transmits the data when the clock signal in SCL line goes high. So the SDL line checks the bit, that is whether it is 1 or 0. So only at certain instances, certain clock periods, the data transmission takes place. It is because of this reason, Ethernet does not guarantee the transmission of data. So it is used in applications when the network does not have to meet any rigorous real-time requirements. Coming on to the physical organization of the Ethernet network. Ethernet network is a single bus and all the devices are connected to the bus. The network is a bus with single path. It can be either a twisted pair or coaxial cable. Nodes on the Ethernet are not synchronized. They can send their bits at any time. Therefore, when two devices try to send data at the same time, the message will be ruined. The Ethernet arbitration scheme used here is carrier sends multiple access with collision detection, CSMA-CD. This is the flowchart on CSMA-CD arbitration scheme. Initially, it is in a stat state. Each node on the Ethernet network checks whether it is properly connected to the Ethernet bus. If it is properly connected, then it can transmit the data required. On transmission, it also checks whether any collision happens, that is, whether it collides with any data transmitted by some other nodes. If no such collision happens, then the transmission can be done successfully. It also checks whether the data from the sender has reached the receiver properly. If it has reached properly, then it reaches the finish state. But at certain times, the nodes might not have connected to the Ethernet properly. So, in such cases, the nodes have to continuously check whether it has been connected to the Ethernet. Only when it is properly connected to the Ethernet, then it can transmit the data. Once it has been properly connected, then the data can be transmitted. It checks whether a collision happens. Once it identifies a collision, then the device has to abort its transmission and wait for a backup period of time and again check whether it is connected to the Ethernet properly and has to continue the same process. Once no collision is identified, it has to check whether the transmitted data has reached the sender properly. If not, then it has to retransmit. Retransmission occurs in cases when the data sent from the sender has not reached the receiver. That is, the data has been lost somewhere between the channel, or some part of the data has been lost, or the data has reached the receiver in a disordered manner. A node that has a message waits for the bus to become silent and then starts transmitting. Once it has been found that the bus is silent, then it can transmit, or else it has to wait for a random amount of time. So each time the bus has to listen to the bus until the bus becomes silent. The waiting time is random, that is, it is an exponential function where the power will be the number of times it's back off. A particular node, when has to transmit a message, has to listen to the bus and should make ensure whether the bus is silent. Until then, the node has to back off, and it has to back off sometimes a number of times. So the exponential function power will be the number of times the node has backed off. The exponential function is not considered in the same manner for back off. Instead, it is modulated with the random factor. This minimizes the chance that the two messages repeatedly interfere with each other. The exponential back-off technique helps to ensure that the network does not become overloaded at high demand factors. The figure shows the exponential back-off function both before and after it is modulated by the random wait time. Since a message may be interfered with several times before it is successfully transmitted, the exponential back-off technique helps to ensure that the network does not become overloaded at high demand factors. The solid line indicates the exponential waiting function, and the other line indicates randomly deterred times. That is, once the random factor is modulated with the exponential waiting function. The random factor is added to the exponential waiting function to ensure that no two messages will be repeatedly interfered with each other. The random factor is new at each times, hence the chance for interference of the same message every time will be reduced. The maximum length of the Ethernet is determined by the node's ability to detect the collisions. Only if the nodes are able to detect collision and to ensure that the bus is silent, then only an Ethernet bus can work successfully. Hence, the length should be adjusted in such a manner that the nodes have the determined ability to detect collisions. For the collision to be detected by both nodes, each node's signal must be able to travel to the opposite end of the bus so that it can be heard by the other side. So the length of the Ethernet should be structured in such a manner that the signal reaches the exact opposite end of the node. The distance that the signal can withstand or travel should be considered for the building the Ethernet. In practice, Ethernets can run up to several hundred meters. So, finding the length of the Ethernet is an important factor for its proper functioning. This is the Ethernet packet format. It contains preamble, start frame, destination address, source address, length, original data, padding, and CRC. We'll discuss in detail on each one of them. Preamble. Ethernet frame starts with 7 bytes preamble. This is a pattern of alternative zeros and ones which indicates starting of the frame and allows sender and receiver to establish bit synchronization. Start of frame delimiter. This is a 1 byte field. It indicates that upcoming bits are starting of the frame, which is the destination address. Destination address. This is 6 byte field which contains the MAC address of machine for which data is destined. Source address. This is a 6 byte field which contains the MAC address of the source machine. As source address is always an individual address, the least significant bit of first byte is always 0. The next field is the length field. It is a 2 byte field which indicates the length of the entire Ethernet frame. Data field. This is the place where actual data is inserted, is also known as payload. This is the padding field. The next one is the CRC, cyclic redundancy check. Cyclic redundancy check CRC is 4-byte field. This field contains a 32-bit hash code of data which is generated over the destination address, source address, length, and data field. If the checksum computed by destination is not the same as sent checksum value, data received is corrupted. As we have discussed, Ethernet was not designed to support real-time operations. Since the nodes in the Ethernet bus are not synchronized, they can send the data at any time and there are more chances of collision and there is no guarantee that the sent data reaches the receiver properly. The exponential backup scheme cannot guarantee delivery time of any data. Today, many different approaches have been developed to extend Ethernet to real-time operations. Some of them are compatible with the standard while others are not. Next one is Fieldbus. Fieldbus is a set of standards for industrial control and instrumentation system. As an example, H1 standard uses a twisted pair physical layer that runs at 31.25 MB per second. It is designed for device integration and process control. Next one is high-speed Ethernet standard is used for backbone networks in industrial plants. It is based on the 100 MB per second Ethernet standard.